So this video is going to be a quick overview on my Nautobot MCP server and just kind of give you an idea of kind of what it does and how you can actually use it in your VS Code. It's primarily designed to be used within your IDE. And so I have Copilot, but you can use something like continue, cursor, or something along those lines that you can, use an agent, and the agent has to be able to use tools. But essentially, the actual MCP server, how it starts is your Copilot agent initiates an action or query based on what you type in here. If you have it based on agent mode, it'll automatically decide what it wants to use. But based on your initial action or query, it will select an available tool. In our case, tools that we have available are some built-in stuff, run tests, search, and whatnot. Search is actually kind of cool because it looks for code within your workspace. So in theory, if you have a workspace created with a bunch of Nautobot related code, this will do exactly what my MCP server does. But a lot of people kind of want a built-in solution that you can have kind of on its own or running in a container. So you're not really going to have it in an actual IDE. So it might not work for that. But if you have this plugins or everything kind of running locally, you kind of can run by this. But the MCP server that I currently have is my Nautobot MCP server. And there's about 10 tools here. Dynamic API request, a knowledge base for initializing, adding, listing, removing, and getting the status update of my repos. Also, the actual semantic search of it. And all of these tools are essentially ways for you to add, remove, list, and have the agent use the vectorized repositories that you can configure based on whatever it is that you're working on. And then finally, we have the open API request schema, as well as the refresh endpoint, as well as the dynamic API request, which is what actually interacts with Nautobot API. So essentially, based on your query, finds available tools, and based on the tools, it will call the Nautobot MCP server, which I have configured, and then it will select one of the tools that I have, right? So API search, knowledge base search, both of those use the local embedding model that is currently configured. The reason why I have it configured here in models, and it's already kind of in the MCP server, is because one, it was small enough that I can just have it, and two, my workplace actually doesn't allow us to have external models. So this is some workaround that I was able to do for me to be able to run this efficiently. Um, in version 2 of this MCP server, I'm actually going to have multiple models that are good at specific things and possibly have it summarize chunks of data instead. I might also have a version 3 where I do leverage workspaces, where instead of having to create semantic models and everything within the actual ChromaDB that I have, it will just add pull down repositories that you want and add them to your current workspace, which will be in this MCP server, so that it can automatically perform all the actions that it needs to. So that's one of the two things that I kind of want to do, and hopefully I'll have some time to check that out. But that is the tools that use the local embedding model, and they return K amount of endpoints or searches, which are part of the knowledge base. And then you can also do, like I said, list, add, remove statuses of repositories. You can fetch the API schema or get an update of things that it might refresh, initializing really the endpoints. And then finally, dynamic API request tool, which is how it actually responds and uses Nautobot. So it does not actually return tools, it returns endpoints for then your agent to know how to fill in a request. The reason why I did not return tools is because if I go into the IDE and VS Code, you would have like 1,500 tools here if I were to return everything, because they would all show up because each one of these is an actual tool. So I didn't want it to be cluttered. So this was a workaround that I did, but that will be something that I'll probably look for and maybe update in a different version or a different branch. But for the sake of this, I'm gonna spin up a Nautobot instance just so that we can kind of get this started and see how this works. So go to quote space here. Now I'm already here. And then I'll go to tutorial, invoke, debug, and I'll have that launch. And so essentially, all you need to do for the MCP server is copy the environment example, which essentially you can define, API timeouts, the embedding model if you want to switch it up, the default searches of things that it can return. So it defaults to 5, but it can do more if you specify it. You'll need a GitHub token in order for it to actually pull information from your GitHub, and you need an Autobot token for it to actually perform any actions for you. Other than that, everything else, you probably stay the same. Non-prod and production environment, this is just so that you can switch back from environments. So in my workspace, we have non-prod and production. So I do actually have these enabled in my workplace. So I can quickly change my environment to non-prod or production, and then I can actually interact with each of those environments. So back to the image that I have here. If I go to docs and image. So I can quickly say, how many devices do I currently have in Nautobot? So just a simple query, right? How many devices do I have configured in Nautobot, right? So first thing that it will do is it'll do a get DCIM devices params limit 1. It just knows to use that, and it's running my API request schema, right? So I'll hit allow just so that it can go and do its thing. And this is the exact tool that it called, dynamic API request tool. So after it does that, you can see within my actual terminal, since I have it in debug mode, you're gonna see what it actually does to get that information. So API Swagger JSON, it was the actual, in the backend, it's actually getting context for this. And then as you can see here, it's doing the query params on getting the devices. And you can see right here, API DCIM devices, limit 1, dep 2, and now you can see here, API returned a count of 2 devices, device 01, which is Cisco 2951, located in DFW with access status 2. So I can see one of them in the response, right? Would you like me to get more detail about all your devices? Yes, get me the details of all my devices. So once I do that, again, right, it will do a GET request and do all the stuff. So there we go. Got all the detail for 2 devices, device 1, device 2, and it gives you a summary, right? Like they're both located in DFW, they're both 2951, they're both in active status, and it gives you a high level idea of all of those things. And you can go even further, right, to ask for serial numbers, asset tags, et cetera, et cetera. But the cool thing is that since it's interactive and it's using all of the APIs that you have, when you go into your actual Nautobot instance and you go down here at the bottom of an API, all of the APIs here is what it discovers. So everything here is a tool that can be used by your agent. So if you have specific plugins that you have that are only available within your organization, it will discover them at runtime so that you don't have to, reconfigure or do anything. It will just automatically refresh this and get those endpoints so that it can work with it. So I don't have anything else because I have pretty much bare bones here, but you can do whatever it is that you want. I could easily say, let me see, rack, right? So this is a rack. So I don't have any locations for rack. So I'm gonna go to data center and I'm gonna add this to rack. So now I can use rack. So now we can have rack, right? And there's a status, there's no roles, tenants, it doesn't matter here. And I'm gonna say, and this is just so that we can see, can you create a rack and add both of these devices one on top of each other. Please add them. Please make this rack location be DFW. So the more specific you are in this, the better it is for it to know what you want. If you're very generic, it will try its best to do things. If you're very specific, it's very good. So right now what it's doing is trying to get everything that it needs to. So I'll go through this in the back as soon as it's done here. Yep. So I'm just hitting allow just so that I can move this demo along. And there we go. And I'll go through this one more time so we can kind of see this. And if I go here and refresh it, we have rack 1 in DFW, and you can see here the devices 01, device 02, one on top of each other. And if I were to specify, give me device 1 on, slot 35 or 34, then it would do it. Right now, it just decided to pick the first ones that are available. That makes sense because it's there, and then it even added comments here for you. But if I go back to the actual MCP server, we'll go down this list. So first thing it does, it's a query, right? Create a rack. So it does a query on my endpoint, and then it gets back matching endpoints of like, these are the things that are related to racks. So after it gets that demo or that info, then it does another query, rack creation schema requirements. Again, it gets more endpoints back. Then it does, let me first check what rack roles are available. So then it says get roles, and I need the contents for DCIM racks. 0, I have nothing. If I would have specified make the role this, it would have also done and created the role for a rack and then added it to it, which I can do right now. Then I finally do, it says give me all the statuses for DCIM rack. So you've got 5 statuses here. I didn't specify what status, so it assumed active. But if I was specific, then it would also make it specific as well. And then finally, it says now create the rack in the following location, right? Because now I got that information. So if I go to this endpoint here, it says post, DCIM racks, rack number 1, this is the location, this is the status, height, false, and the comments. And that's the actual post request. Great, it's been successful. Now I need to update both devices and assign them to this rack and position them. Since each device is 2U high, I'll place device 1 and 02 at the bottom and 2 at the top. So it does front, patch, DCIM devices, the body rack, position 1, front. So it patches a device, which is this one, and assigns a rack position for it. Now for the second one, same thing, front, position 3, and updates that device. And then finally at the bottom, it tells me, okay, I've done it. This is what it is. This is the quick rack details. This is the device positioning. And then it even gives you a little diagram there for you. And now you can quickly go into these devices and see its position U1 front, and it's in the rack. So that's what essentially Nautobot MCP server is. It's a way for you to interact with Nautobot just with straight plain English. And this can be very good to just add information that you need on the fly, get information, post information like I did. But really where it comes down to is for you to leverage this to create custom information. So if I go to example job, this is something, I'll actually go to this one. This is something that it created entirely using documentation from Network to Code. And I currently have, if I go to my backend KB, I currently have Nautobot, Nornir, and PyNautobot configured, and that's in my config. And I go to repositories, I have Nornir, I have PyNautobot, and then I have the core Nautobot. And then user repositories, I don't have anything. But if I go to this demo, this was 100% established and created by the agent using the best practices from PyNautobot. And this is essentially what I asked it to do. I said, I need a PyNautobot script, find the devices and interfaces connected to circuits via cables, And I said this script follows best practices because find all devices, get interfaces, filter, and I needed to return a CSV file for me. So with that information, it did queries to the actual knowledge source, which is the Nautobot GitHub repo, and it created this whole thing for us. So it created a class, functions, alternative cable approach if it doesn't find things, finally saving it to a CSV. It created a main with URL and tokens, try, accept, print statements, and finally it's a full-fledged script that you can do. And this is something that you can just do on the fly. Same thing for this. This was just a simple create device job. Like give me a, create a job, not about job that does create a device, and that's it. And this is what it does. So using that to create something for you is very powerful because documentation is very, sometimes can be either very lost or not enough, and you having to go in and find information. And I have good examples. If you have something that you can pull either repos that are internal or repos publicly sourced like Nautobot and directly use that code to get information, you can leverage agents on top of the API calls, but to write custom code for you. So I can easily just go into my Nautobot tutorial, which is my actual working Nautobot instance, go to jobs and put device type creator .py, and I could say new. I'll go to new thing here and I'll put to do, and I need to get this real quick. GitHub netbox netbox device type, and it's this one right here. Device types. Here we go. To do. Leverage netbox to get YAML configurations for device types. Let the user pick the manufacturer, folder, and device type name file. Get the YAML file and create a device type in Nautobot. This is going to be a Nautobot job. So using the to-do, please create the Nautobot job to leverage the netbox repo, GitHub repo, to fetch the YAML configuration for device types so that the users can dynamically create them in the UI using a Nautobot job. So pretty simple. Write a to-do list, and it wasn't very intense, and I probably should have made it easier to read. But if I do that and write it out, it will try to search the code base that I have and see what it can find. And right there, KB semantic search. So it's going to try to find the query that it needs within the ecosystem to see what it can find and see what information it can use to leverage and write this for it. So I'm going to just put allow for this session because I know what it's going to do. It can query this multiple times, or it can query it only once, but I'm going to go ahead and let it kind of run and get all that information for us. Yep, allow for the session. Yep, we'll add that. We'll delete that. And we'll go to the creator. So success does not work. So I'm going to just put info, change all those. And let's just see without doing anything if it works. So if I go to jobs, and I go to tutorial, invoke post upgrade, and that does its upgrade. We should see this job just randomly. Yep. And let's just see if it even works. I'm not going to read the code or anything. I'm just going to assume that it works properly. So here we go. Create interfaces, create console ports, create power ports. Realistically, I wouldn't have these as variables. I would just always do it. I don't see any reason why you would never create interfaces. Like, this is the whole purpose of using this library. But let's just assume, right, I want a Cisco. And I'll just go to Cisco so I know what I'm trying to import, because I don't know them at the top of my head. Let's just go to something that I know. ASR 5540. All right, so let's assume this is what we want. ASR 5540. If the code works, it should get that YAML, fetch it, and create that for us. Go to device, device types, 5540, 5 interfaces, 1 console, 1 power, 1 module. And if I go here, 1, 2, 3, 4, 5, there's 1 management. There's 1 module, 1 power port, 1 console. Is there 1 management port? Yes, there is, and it's flagged as management. So you can see that's the power of using an agent and also using knowledge from the actual documentation. So maybe you could have done it with just using workspaces, but using something like semantic model, it actually fetches information, as well as using the API to verify things that need to be created, such as like required fields, so that it actually does the job correctly. So overall, it seemed to work pretty dang good. Let me actually double check this. TX and TX, yep. So everything kind of worked good. So that's just a quick demo of the Nautobot MCP server. This is available publicly, so you can just use it. This is just something that I created, but it works pretty dang good on VS Code, and you can really make it work, especially locally. You really just clone it and start working with it. As you can see, I'm just working on it locally for Nautobot, but you can do a lot of cool stuff with it. So that's it for this video. Thank you so much for watching.